Hey guys, Taylor here from SSV, one of the sponsors of ETHOnline 2024. In this video, I just wanted to walk through one of the three bounties that we have up for grabs. The one I'll be talking about today is best use of SSV data. So there is 3,000 US dollars up for this one, and two projects will be eligible to win prizes. So for this video today, the content that I want to go through, first of all, an introduction to SSV ourselves. It'll be a brief one. If you want a more detailed introduction, you can check out our other workshop, building a restaking dApp on SSV, which will also be uploaded to the ETH Global YouTube channel. I want to talk a little bit about dbt, which is the core technology of what SSV is built on. I'll look into the SSV smart contracts because that is what manages all of our on-chain data. Subgraph, which is the indexer we've chosen. So essentially, this stores all of the information that we need and makes it usable to build applications and such. And then a code tutorial, just a very brief introduction on how to actually work with this code. So a little bit about us. SSV was founded in 2021. We've been in mainnet for around a year now, and we've been in testnet for 2 years. We have our own token, our SSV token, which is used for paying people in the network. We have a grants program as well. So if any of your projects are really good and you want to continue working on them, and it's really valuable to our ecosystem, you can also apply for that after the hackathon. SSV itself stands for Secret Shared Validator. This is kind of the original name of DVT, which is now known as DVT, which is a distributed validator technology. Essentially, at a high level, this is the next level of staking. And if you don't know what DVT is, that's fine. I'll get to it in the next slide. We have this really great network here, this infrastructure based all around DVT and this technology. Currently on mainnet, we got 39,000 validators and we have 800 plus operators, which are working on the duties for these validators. And within that, we got 800,000 ETH staked, which is like 2 billion USD at the minute. So from only being on mainnet for a year, we've had a really good year so far. What actually is DVT and how does this work? For staking in Ethereum, the kind of original flow or current flow is that if I'm a solo staker, I will generate a validator key. I can run a node with some software on it that must always be online, so I can do any duties as a validator that I must do so I can get paid and get my rewards. Obviously, this comes with some downsides. So the validator key having to be always online and ready to sign transactions. The fact that we have execution in the consensus client, both all in one node, means if this node goes down, we can get slashed and we can lose some money. DVT is the next step forward in terms of staking to make this a bit better. So instead of the validator key just being on one node along with everything else, we can split this validator key and we can pass it out to what we call operators. The operators themselves, they will run the execution, the consensus, and the validator client on their own nodes. And when it's time for a duty for this validator to be done, it means only 3 of the 4 of these operators need to be online. This has two really important things. One, we can leave our validator key in cold storage. It doesn't have to be online always, which is a lot more secure for us. The other thing is that because we have 4 operators instead of just 1, so pretty much 4 nodes instead of the 1, which always has to be online, it adds a lot of fault tolerance. So the validator themselves can feel a lot more secure because if one node goes down, they're still completely fine. The duty will get carried out and they will still get rewards and they will not get any of their ETH slashed. Another important point to mention is that with this setup, compared to the current flow, we get client diversity within the operators. So because the operators can use different nodes in terms of where their location is based, different execution clients and different consensus clients means there isn't one single point of failure. You know, if say there's a problem with the execution client, like a bug within the execution client itself, if the other operators are using some, a different execution client, which is running completely fine, it means the duties can still be carried out and everything will still run correctly. So with the SSV network itself, you're probably wondering, what is our role within the DVT landscape? We have our own decentralized, secure, permissionless, and scalable DVT staking infrastructure. Essentially, what I'm saying here on the last slide, the way we have the validator and the 4 operators, you as either a validator who wants to stake ETH or an operator who wants to run nodes in networks, you can join as either completely permissionless, completely decentralized, and you can either earn money as a validator with your staked ETH, or earn money as an operator by carrying out the duties for these validators. And you will earn money in SSV token that way. This is all managed through an SSV network smart contract. As we can see here in this example, if I'm a new validator, I come along with my key. I need to register my validator to the SSV network smart contract. So I will choose a number of operators, whoever is looking good, whoever has good performance, and then they will take it from there as they have the shares of my key. 3 of them can sign for the transaction, and we're all good to go with our staking setup. So the main point to think about here is that we have the separation of roles between the validators and the operators. The validators, like I said, being the ones that want to come in, they want to stake their ETH, and they want to do it securely. On the other side of that, the operators are the ones who are running the show. They have their node set up, and they will make sure this all works correctly. Because we have this staking infrastructure set up, and the operators have a similar thing through their whatever that way they want to do it, through cloud computing or their own bare metal nodes, however they want to run their nodes. We have this really good network and infrastructure that allows either party to easily add or remove from this network. So the contracts themselves, there's 2 of them. The first one is the SSV network contract. This is essentially the contract that manages everything on SSV on chain, handles validator and operator management, 2 entities we've talked about before. The third is the account. So this is essentially just a wallet address that will manage any of the validators or operators that I've signed up on the network. So if I sign up a validator on the network, I'll have my MetaMask or something, my wallet in there, and that address that actually owns this validator, that was what constitutes as the account. Also, we have DAO governance on this contract. So any of these decisions that are made, something like a network fee being changed, it must be voted on by the DAO, and then that can be put in place on the contract once there's enough votes. The views contract is essentially just read-only functions. This is just an easy way to get any up-to-date data on what's going on in the contract. So this is useful for things like debugging, when you want to get a quick check on what's going on, but it has its limitations in terms of we can't get historical data from this, and we couldn't use this within a web app because it would overload the RPC node. So we need a different solution so that we can get all of our up-to-date data programmatically through API calls, and also have all of the data saved historically. One thing we want to think about here with the smart contracts is the contract events that are fired by the SSV network contract. So anytime anything is done, any action is carried out, any transaction is made, we have an associated event for each one of those contracts or each one of those functions. To give an example of what this kind of looks like, I'm inspecting this register validator transaction that I've run using BlockSec. So you can see here, I've called the register validator function. So in this function, I've put in all my validator details, and I've selected 4 operators that I want to manage my validator. The transaction goes through okay and registers in the contract. One thing that's interesting here is that this event is fired, this validator added event. We have some software that will look at all of the events, get the data from the events, sort it, and then put this into this really complete, great data set that can be used for building applications, for querying the data, pretty much anything. And this is what we're using for this. So we are using Subgraph to achieve this. Subgraph itself is a decentralized indexing protocol used to organize blockchain data. We have a bunch of functions built out for Subgraph to tell it to pretty much look at any of the events that we fire off. It'll look at the events, it'll extract all of the necessary data from those events, it'll sort the data correctly, and it does this by using custom logic that we have built ourselves, and it'll store it in our Subgraph database. This means we have a really great, really usable database of a complete data set of anything that happens on with SSV on chain. There's 2 ways to access this data. One of them being the playground, which is what I've showed a screenshot of. This is a really easy kind of plug and play, like you can select the options of whatever's available to build your queries up in GraphQL. And then as you can see here, you click the little play button and you get back all the data. So here we were just looking at operator ID 10 and we just want to get the public key back. The other way to work with it is using the API. So this is the programmatic way of doing it. This is what I'm going to show in the code tutorial in just a minute. The bounty itself, best use of SSV data. So it's $3,000, first place being 2,000, second place being 1,000. The idea behind this is that we have this amazing, really usable data set, of everything that happens on SSV network. And we just want to see what people can build with it. It's really easy to work with and use, like you'll see when I show you in the code tutorial here. We just want to see what great usable applications people can build using this data. So now we're going to move into the code tutorial part of this workshop. This is going to be a very brief tutorial. Essentially, I'm just going to show you how to use the SSV subgraph API, how to make a request in JavaScript so we can programmatically run any of the queries that we build in the playground, get back that data, and then at that point, we're free to use the data however we want and display it. So we'll start just by opening my terminal here, make a new directory called SSV data. I'll go into that here. We're just going to create one JavaScript file here. I'm going to call it fetch-data.js. Just going to import one library, node fetch. So this is the library we're going to use to actually make the request to the subgraph API. And then we're going to open it up here in VS Code. So we'll start here just by opening our fetch-data.js file. And we'll start off by importing our fetch command, which we're going to use to run the request. Also in the setup here, we are going to define our API URL. So this is where we're actually going to make the call to. So on our docs here, on SSV subgraph, and the SSV docs, if we scroll down a bit here, see we have this developer API section. And I'm just going to take this URL here for testnet. Obviously, you can just take the one above for mainnet if you're going to develop something on that. And then the third thing we're going to define here is the query that we actually want to run. So for this, I'm just going to head over to the playground. This is this link can also be found on this page. So this is essentially what we can use to build up. It's a really, really easy way to build a query, because as you can see on the right here, we can just kind of click through it. I'm just going to query operator 100. I'm going to, what am I going to select? I'm going to return the operator ID, and I'm going to return the validator count for this. Click play. And then as you can see, in the playground, we've returned this data. It's got a validator count of 9. So what we want to do is we want to take this query, and we want to get that getting output in our code. So I'm just going to put that in as our query right here. Okay, now we're going to go ahead and define the actual function itself. So just define an async function here, call it fetch data. And we will start by defining a try catch. So we want to try catch here because we want to send, or we want to make the request using fetch to this URL with the query. And if there's any errors, we want to understand why there would be errors and log that back to the console. So we'll start by defining our response variable here. So this is because we want to obviously get back the response from the fetch command that we're going to use. And we want to save that so we can output, so we can format the data and we can output it correctly. So start by defining the method, which is it's going to be a post request. Yeah, and then we will define the headers, which yeah, we want to set to the content type. Sorry, content type to be application/JSON. Okay, that's all we need in the headers. and then the actual body, so the actual request itself, the query that we've defined earlier. We're going to format that correctly, so we're going to use stringify here. Within the function, we'll put it in squiggly brackets, and we will pass in that query. Okay, so if that response, or if that request works, then we want to format it correctly so that we can output it to the console and it's readable. So we're going to use this await response.json, lowercase here. And if that all works correctly, then we can just hopefully output this response data. Now for the catch part of it, this will be a very simple catch. We're literally just gonna look for some errors, output the errors to the console. Now that that function is all done, we actually want to just call the function when we run the script. So yeah, let's give it a go. I'm just going to use node to run the script. Run our fetch data.js. And there we go. I put it in JSON format. Essentially exactly what we saw in the playground. The operator ID, the validator count. Super fast requests. Really easy to get the data. Obviously there's a lot you can do in terms of the way we can sort the data, how you can build the queries yourself programmatically. There's a lot of options, so hopefully this kind of gives you the building blocks to really get started with this bounty. So that's it for the code tutorial. Now I'm just going to run through a couple of examples on what could maybe be built for this bounty. The first being some account owner dashboard. Say I'm an account owner on SSV. I have multiple validators. Maybe I run some operators as well, all under the same wallet. If there was some dashboard that I could code to and just paste my wallet in and get all the statistics about everything I own, that could potentially be very nice. Some metrics aggregation could be cool. So we have all this data here about everything in the network. If that could all be put in one place with a bunch of like charts and dashboards, so we can get an overall feel and look on how the network is performing. Kind of like June a little bit, except I guess more up to date and just completely like on track with what is going on in our contracts. And then this other one, I guess this will be more on like actually changing the subgraph itself rather than building using the subgraph. Essentially, we store every time like an operator is changed, we update it with the new data, but we don't have any historical data on that operator. We don't know what it was, what the changes it went through previously to get to its current state. If there was some way to basically save every version of that operator that we store in the subgraph, and then being able to present that so we can see how it changed throughout each time it was updated. Something like that could be very good. But yeah, this is just a couple examples anyway. And anything, if you're interested in doing any of these, the team at SSV, super happy to help with any of these ideas you have or any other ideas you have. Like, we're just like super keen to get people building with this sort of thing. As you can see here, I've got the GitHub as well. This is the code for the SSV subgraph if you want to think about doing this third idea. That's pretty much it. I've got some links here to the docs, our prizes, and to the subgraph itself, the GitHub. We're really excited for people to be building with this. If you choose this or our other bounties, really happy to be sponsoring ETHOnline 2024. And yep, happy hacking, guys. This should be good fun.